This conference will now be recorded.
Hi, so good morning, good evening to everyone. This is our 17th meeting for the TAP project. And this meeting will be dedicated for kicking off our fourth work stream, which is focused on hardware, specifically oscillators, when it comes to TAP appliances. And before we dive right through, just some updates on where we are with our project. So up until now, we've been working on mainly two streams. One is the open source Grandmaster, the document that covers the requirements for an open source Grandmaster in a data center or edge environment. And we have good progress there with samples coming from different vendors and the document shaping up. There have been a few discussions and calls on Dislegal. The other work stream, which Michelle is leading, is with the PTP profile. And just recently this week, we shared the requirement document with the OCP networking team. And there's been very good collaboration with different TAP members and from different companies and associations applying their feedback and their knowledge into the document. Will also help now to extrapolate the requirements from a switching device to support the PTP profile. So work is still in process in this space, and your feedback and collaboration is very, very helpful for us. Michelle, do you have any next steps or meetings that you want to share with the team on the PTP profile?
Yeah, quick update. We've received 62 comments from 5 different companies.
Impressive.
To date, so this is a really good thing. I would say half of the comments have been reviewed and somewhat resolved, and now we're just plowing through the remaining of them one by one. I wish it would be a little bit faster, but I hope that in the next probably 2 to 3 weeks we can provide a solid update on the resolution of all these comments.
Awesome. This is great. So I appreciate the team collaboration, the whole members here. This is going on as we would like to have with the all our other work streams. And the focus for today is for Gary from SciTime, who is volunteered to lead the fourth work stream for oscillators to put a framework for to collaborate and to define means to measure and classify oscillators. I will not steal, Gary, I won't steal your thunder. What we'll do today is try to define the problem and define the way that we want to approach it as a team. So I expect this to be, leave your microphones open, and I expect this to be a very fertile discussion, not a monologue. And I will pass on the keys to you, Gary, so you'll be the presenter.
All right, thanks a lot.
Okay, I think you have it.
Okay, can you see my screen?
I can.
All right, perfect. All right, so today we're going to provide a framework for the oscillator workstream. It's a fairly short presentation. We get about 5 content slides. First, I'm going to discuss why we created the oscillator workstream, what we expect to be the desired outcome, and then start with the framework of how we're going to work to create specifications for oscillators. The emphasis here is a framework and fleshing out comments and suggestions from the community. And then finally, we'll summarize that with a methodology to move forward and a call to action. So why did we create the oscillator workstream? In conversations I've had over the last month or two with people in the community, technical peers in the community, the feedback I've received is that when hardware vendors are evaluating oscillator data sheets, it's not straightforward or clear what parts of the data sheet are the most important or how to translate the oscillator data sheet into PTP performance in the network. For example, the banner specification of a TCXO or an OCXO is typically the frequency over temperature stability, which actually doesn't play much of a role in PTP networks. It's more about the frequency versus temperature slope that we talked about in one of the previous classes, one of the previous sessions for OCP TAP. So how do we distill the datasheet requirements into the most relevant critical parameters for PTP network? And also, typically the datasheets will include a fairly wide temperature range. For example, -20 to 70 degrees C or -40 to 85 for extended commercial and industrial temperatures, for example. But data centers have a very specific environment that would be a subset of that full temperature range, and customers should want to know and ask what is the performance they can expect from the oscillator given that more subset of a temperature range, which would be relevant as well. Holdover is another area where there's a lot of interest in the industry to have more well-defined specifications. Holdover typically is the performance you get in holdover is a very large function of the temperature profile, including the ramp rate, the airflow profile, how long the device has been turned off before it's powered on, and the warm-up time. So there's many variables that impact the performance that aren't necessarily communicated on the datasheet and require conversations with the oscillator vendors. And those conversations are the results of those are different depending on the oscillator vendor that you talk to. And so that also creates a need for the hardware vendors to collect the devices themselves and measure it in their laboratories in order to get an apples-to-apples comparison and really understand the performance of an oscillator. The other aspect would be the oscillator data sheets. It's not clear what the statistics are on the maximum specs. For example, are they 1 sigma specs? Are they 3 sigma? Are they 6 sigma? That's also varying between vendors of these products. So all these things make it difficult and time consuming to select an oscillator and require the hardware vendor to make assumptions or to have communications with the vendors that are unique for each vendor and require them in some cases to retest the datasheet specs and verify the performance levels. So that is one of the issues that the industry is facing today. And when they integrate those devices into their systems, the performance that they get because of variations in the manufacturing of the oscillators, the system performance can also vary, and the test results can also vary. So it leads them to select other components and go through the process and iterate. So all of this takes more time and resources. So and so that's another motivation for this oscillator workstream. And at the end of the day, sometimes even the operators, the feedback I'm hearing is the operators don't always know what to ask for from a PTP performance and relying on the hardware vendors, which are then relying on the oscillator vendors. And so by having a dedicated work stream for oscillators, I think we can flesh all this out and try to get some consistency to create predictable and repeatable PTP performance for different levels of PTP performance, because not everybody necessarily wants the same level. And so there'll be different price points as well. The desired outcome.
I can definitely relate to this motivation. Let's just see if there our members have any, are just nodding and the cameras are off, or if they have other points to add. I'm asking our members who are system integrators or operators if they have. I assume you're facing similar questions and wanted to get your feedback here.
One thing I wanted to ask Gary is when it comes to, for example, quote unquote, I'll say like smart oscillators, where like, and by smart I mean smart is being like abused as word. So like whenever you have, let's say, a console like a serial port or something that you can communicate with that device, like either it's an OCXO, it's like a atomic clock, rubidium clock, like miniaturized cesium clock, you name it. So there is always a different protocol for each one of them. Like one of them, let's say, I don't know, uses like I don't know, I came across Samsung, I guess, was using like some binary thing, and then I came across like one from Microsemi was using, let's say, an ASCII, but then the like I don't know, the speed was different than another one. Like each one of them, they use their own thing. So wouldn't that be good if we can, let's say, have at least some common things? How we have, let's say, GNSS also like a mess. Everyone is doing whatever they want, but at least there is the anemia that if you use anemia, then everyone knows what you're talking about. Like you basically can often go in the console with their proprietary thing, enable anemia after the stream is all anemia. So perhaps there is, I think, the potential to make some of these things, let's say, a little more standardized, even the steering or like, I don't know, all kinds of things. There's so much, I think, in this that we have these vendors, each vendor, I make, that's pretty much your world. Like that in that sector, you have every vendor trying to, I don't know, for whatever reason, it often is more, there was nothing, there was no standard, we came up with this, we think it's the best, and then everyone thinks that way. While if there was something that it's not necessarily the best, but is like the one that covers the most, then we can take that as a standard and everyone starts to follow on that. What do you think about that, Gary?
I think it's definitely something that we should discuss with the community. I can see the benefit of it because in a lot of cases, from a clock or oscillator perspective, you are doing the same thing. You're tuning the output frequency, you're reading the temperature, you're checking the health status. These are all common requirements for that serial port. And the protocol and API is probably associated with that. I think it's a good topic that we can raise as part of the work stream. Does anybody else have any comments on that topic? One way or the other?
Well, perhaps like another thing like I wanted to also ask Gary is, for example, you guys have this the like jitter cleaner products or something. Perhaps we can have those things also bucketized and categorized a little bit, because that's like, where do you go now from the oscillator? Like you have the oscillator here, and then we have to have like I think that should be also part of the oscillators, because often you have this mismatch. Like I mean, if you want to stick to, let's say, these high reliability, high performance in holdover clocks, they all go around 10 megahertz. While depending on what you're dealing with, is a NIC or something, you have different frequencies. So perhaps that should also sit in the same bucket, because combining the jitter cleaner with the oscillator, I consider that now a low jitter oscillator. Think about like system level.
Yeah, definitely the jitter attenuator is used in the 1588 survey as a way to steer to lock to the upstream master. And certainly if there's you lose the lock to the upstream master, then you have holdover. And the way that you go into a holdover and come out of it, maybe there may be some requirements in the data center that might make it different from others. I'm not quite sure. Also, the bandwidth of that jitter attenuator could play a role as to the system phase noise that you'd like to see at the output. So the clock jitter attenuator product itself could have system implications that may see a benefit in rolling it into the oscillator workstream as well. Again, that's something I'd like to explore with the system vendors, the hardware vendors, to see where the requirements would line up and see if it'd be necessary to bring that in. But I do think that that would be interesting conversation to have.
I think the motivation. Please, Dan, please continue, Dan.
What about Syncki and how using it would help choose or, an oscillator? In other words, if I have a master for Syncki, I probably want really good oscillator. But if I'm a slave on the Syncki, do I put as much effort into it as, I would need? In other words, could I not put as much effort into it to making it less jitter or less?
Yeah. I think that's a good question, because there may also be a requirement for Syncki in the data centers, but Syncki is a fairly, I mean, it's coming from ITU-T, so it has its own set of requirements that may or may not be desirable for a data center. I give you an example. If you don't have holdover in your data center as a requirement for that particular node, then you don't necessarily need to have 4.6 ppm stability for the course of 1 year as a requirement, because if there's no traffic coming in, as an example, then you're not too particularly concerned about the connection going out. So there may be some ways we can adopt the Wander characteristics, the MTI-ET dev, to ensure Syncki compliance in that sense, but maybe some other areas that we could give up that's part of the work that we do here. I'm just thinking off the top of my head, but this is definitely fertile ground for exploration. I think that it's all really good topics.
Yeah, it's Greg.
I just see.
Add
Oh, go ahead.
to that. The one advantage of the ITU-T though is they've done a lot of work already. They've got people there from members from both equipment operators, silicon providers, oscillator vendors, and a lot of simulation has been done. Network limits have been defined, and so I would say it's best to try to reuse as much as possible from them, because it becomes almost a freebie. They have already put the effort in to try to define these into measurable capability. And because of that, it makes it very easy for people to develop equipment and then claim quote unquote compliance as a clock node, as an individual node, not necessarily having to worry about the overall network limits, but at least they can define the node limits and make sure they meet it. And that in turn can help operators then develop their networks, which most of them also do that through the ITU, but there's nothing preventing the data center to define their own networks, but reuse the concepts that have already been defined by the ITU without reinventing the wheel. By moving away from that, that's the issue, is then the data center have to put in the same effort to understand the impacts by either relaxing or removing certain characteristics, and it just may not be worth it. Because of the way the telecom has done it, a lot of these components costs have reflected and have become cheaper, so that things like Syncki and concepts like that have become fairly cheap to put in, and most equipment vendors now even just have it there as a freebie. So to not take advantage of it may be a huge oversight type of thing. So that's just an example. And even on the PTP side, I would say there's been a lot of work there as well. And they've taken two approaches, which I think is very similar to what the data center is looking at, where one approach is full usage of TCs and BCs in the network, and the other is partial or no usage of TC and BCs in the network. And they've done similar characteristics and measurements on that. So I think you should keep that in mind. The ITU is always a good reference for that reason, because there's very specific specs to point to. like for 1588, the key thing about 1588 is the standard is it defines the protocol. It does not define the performance or the expectations of performance. That's the biggest limitation of 1588, no matter how you look at it. Implementing 1588 does not guarantee quote unquote precision, right? There's more to it. So I think that's just one thing to keep in mind.
Yep, that's a great comment, Greg. Thank you for that. I do completely agree with what you're saying. Yeah, I'm just thinking about if there's ways to explore ways to eliminate certain functionality that perhaps isn't needed, then we could save costs in certain ways. But it's definitely an area that we should explore, and I agree we should try to keep as much relevant of the standard as we can. Okay, so let me continue on. So what I envision as the desired outcome would be that we would have a class system of oscillators that cover the majority of use cases that will help people to simplify the selection of the oscillator and promote adoption for different levels of PTP performance in the data center. Not only should we classify the oscillators, though, we should also clarify the test methodology for each of the specs defining the classes of oscillators, so that we don't have ambiguity about how do we measure holdover, how is it defined, that we provide not just the classes but also the specifications in a means to ensure compliance to those specifications. So the classes of oscillators, Elad used a terminology the other day I'm going to adopt because I liked it. He's referring to when you go to the movies and they have PG or PG-13 and R. This would be something similar to that, where if you're going to use a boundary clock in a certain place in the network, then you can go to this particular class of oscillator. And that leads us into the proposed framework. And so what I'm recommending here, and this is just a proposal, we can certainly change it, is that we begin with looking at the applications from a system perspective. And we think about different use cases. The first use case maybe is a grandmaster, a second use case is another grandmaster use case, and we have a boundary clock. And for each one of those use cases, we create a set of requirements. We have input requirements and we have output requirements. So here's what the data center, if the grandmaster is sitting in this location, this is the temperature range that it's exposed to, this is the temperature profile, the airflow, it's being sold for certain ETSI environment, for temperature and so on, maybe it has a certain vibration spec. Those are all connected to that grandmaster. And then there's performance requirements for time error, for holdover, and there's probably a bunch more. My goal today is not really to fill in this system requirements table, as to just show that this is the framework that I'm proposing. So the second step would be, after we have the use cases, to then create a system requirements table. That's just an intermediate step. It's not a spec, but it is associated with an oscillator class, say G1 and G2 for grandmaster. And each one of those oscillator classes has a set of specs that we can define that'll meet the use case. And while we're defining the specifications in this green table, it will be associated with the use case, so that there'll be some transparency, that people understand if they're using G1 from a grandmaster, that it was designed to work with this use case, so that if you're designing a system, you know what it was intended for, and you can make the necessary trade-offs if your system appears slightly different than what it was intended for in the use case. You know where that is, and you can make the associated trade-off. So, and then lastly, the fourth part would be defining the specifications for the oscillator. So what is the temperature range it's designed in? How do we measure that? Is it, for example, the ambient temperature above the oscillator, or is it the temperature of the PCB underneath the oscillator? The first one is more of the product oscillator vendor approach. The second one is more of the system implementer approach. The frequency stability, is that a requirement, or do we go just with DFDT? And how do you measure it? What is the thermal profile, the temperature rate and ramp rate and so on? G sensitivity, is that the relevant parameter that we should spec? Allen deviation, holdover, and phase noise. Some of these specs are going to be easy to figure out and others are going to be hard. I think the most difficult task here is these arrows here. This is a transfer function to take it from the system level spec into the oscillator level spec, and understanding that transfer function in some cases is easy. For example, holdover is mapped pretty easily into an oscillator spec, but there's other specs that, like phase noise, that it's really a negotiation between multiple components in the system. Ahmad mentioned the jitter attenuator, so that'll also have an implication what the bandwidth is, what the inherent noise or the phase noise is of that jitter attenuator. And so this oscillator component spec would be a negotiation perhaps between what's generally available in the industry and the other specs, and maybe a little bit more difficult to quantify. But one thing that the data center has going for it is it's fairly well regulated in terms of temperature, chassis, mechanicals, fans. All these things are much easier they're much more standardized than, for example, a remote radio unit that could be attached indoors or outdoors. And if it's outdoors, on the side of the building, on a pole, or there's many more variables that impact the construction, the mechanical, the cooling. So the data centers are going to be easier in that sense. But I think we're going to face other issues that we're going to work through in the work stream. One would be, how do we ensure compliance? Is this something that we want to enable companies to self-certify, or do we want to send it off to an independent lab, or maybe bring in UNH-IOL or something like that? That's one of the things we'll have to figure out.
So question.
Yeah.
So, going back to the ITU, they've specified these like class A, B, C, and D applications. Would we want to do something like here, talk about precision? If you're going to use a class A, you don't need the precision that you would need for like a class D network, right? And so,
Yeah.
would we want to put that in here, or is that already hidden under, say, time error or?
I think that would go into the use cases. Just my thought,
Well,
but maybe we want to capture it that way.
Yeah, I'm not sure. I mean, a Grandmaster, granted, you'd want to be very precise, right? But some data centers might want to have, your boundary clocks, your transparent clocks, your ordinary clocks to also be very precise, because they want to get single-digit nanosecond, down to the server, or the SmartNIC. So yeah, it's my opinion. I don't know if others have opinions on that.
Are you proposing that there would be like a Grandmaster class A or class B and a boundary clock class A, class B, depending on their precision required?
That's my thought. I don't know if other people have the same thought.
Just to add on this, I think this is a very good question, Dan. As an example, for instance, if I relate to what we're doing in the profile, we specifically call out, some of the ITU specifications. So, for instance, we say the Grandmaster, should be in line with, for instance, like the PRTC-A that was defined in, by ITU. And then you inherent, everything was said, previously about the specification, the masks. You can somewhat derive, the type of oscillator you might want to use in the PRTCA and so on. Now, I think the question is, does that apply also to the BCs or the TCs or, the OCs? That's a good question, yeah.
And then I'd add also, does it apply to the end-to-end? Because now we're talking about individual components, but I can assume that by the time we've developed this and as applications will mature that will use timing, there will be different use cases which will require different qualities or classes, depending on the term you want to refer to. So I can see a need for providing guidance and saying if your target is X or Y, you want a device that's in class or a design that's in class, say A, and another one that's in class C, D, or we use other letters to not confuse with what's being done in telecom.
Yeah, Dan, just to finish my thought, I think we are in agreement, though maybe what I'm calling it is a little bit different than what you're calling it, but I do foresee a need for different levels of precision that would then have different levels of specs for the oscillator classes.
Mm-hmm. I think that makes sense.
Yeah, I agree. So what do you guys think about this framework in general? Does this seem to enable us to a path to move forward? Would you change anything?
I would like to ask Thomas. So Thomas, referring to your comment, where this framework needs or does not need to intercept with the ITU existing classification. I mean, I believe that they've gone through a similar framework. It's just that I'm not knowledgeable about it.
Sure. So I'm sure there are others who know more about it than myself actually on this call. But the point, what I'm trying to refer to at least, is saying, and it's been voiced by others, you're building for different target requirements. We're using the same technology, but as it's been pointed out, you might use it in different ways, or you might have different specific requirements from for the different parts that are in the chain. And as such, you design these different classes. Now, we can do just a cut and paste from what has been done for telecom, or we can decide that there's maybe a need for other classes or different classes that correspond to applications that we either see now or foresee in the future in the data center environment. Although personally, I think there'll be an intersect at one point with the work that's being done in telecom and the backhauls that are being done in data centers. So I don't know if that work would actually end up being redundant or not. I'll let others comment.
Thank you. Any feedback on the framework? I mean, I think getting a readout whether this framework works or not is going to be key for the work of the group. And if we have something substantially different, if you have something substantially different in mind, or to leverage existing work, sort of like piggyback, we would like to hear that.
What do you guys think? Like, I mean, Gary, what do you think about let's say certain let's say procedure of certification? It doesn't need to be necessarily like formal, but it's more like we met this, we met that. So like when the vendors are like going through things, like I think that will address. I think who brought it up, like was talking. I think was Thomas. I think right now. So that like about the redundancy. Well, when you have a set of tests, and then you voluntarily say like we met this, and that just helps us. Let's say then we define those tests, and then we go through things. Like for example, when it comes to, like, to be more specific, when it comes to holdover, it's a statistical thing. It's basically how you deal with the second law of thermodynamics. It's entropy. So you look at this like random walk, and every time you may get a different pattern, and you need probably, let's say, thousands of instances where you can run it, and then you basically look at like, okay, this is how, like, this is the ensemble where you can have everything in between. Like this is the outer and lower bound for where like the holdover behaved every time in this, let's say, last 1,000 tests. So this is like when you combine that with the fact that, okay, for the holdover for every one of those, let's say 1,000, you need to wait, let's say, I don't know, 1, 2, 3 days, then it becomes like really not feasible if everyone wants to test that. Because literally you're dealing with time. You're seeing like how long this thing is gonna work through. Well, if I'm a vendor, instead what I can do is like I have, let's say, thousands of them and I run them in parallel, then I have like the data collected from all of these things and I can present that to everyone. I don't need, like, let's say me as the customer to test these things over and over again, because as a customer I need to know how much should I prepare for holdover. It's really an important thing for me, because like, and it goes not only for Grandmaster, it goes also to my devices, my servers, because that can tell me like, hey, I really don't need to send, let's say, 1 message per second or 16 messages per second, or like I can tweak that literally to my needs. And I mean, I hate over engineering. Like but like you end up doing over engineering when you have like lack of insight of what is really going on there. Okay, let's just do it like this because it's an overkill, it's gonna solve it. I don't like that. Like, and that's like one reason why I want to have this a little bit more standardized and more like deterministic.
Ahmed, I've got a question for you. Oh, sorry, I didn't mean to interrupt.
No, please go ahead.
No problem. Quite good. I finished my sentence.
Yeah. So, so the comment I was going to make is I agree with the sentiment from an end user perspective, but I think we also need to be cautious on how we treat that in terms of each user will have different requirements. So I mean, I like the idea of having guidelines. I also agree with trying to not over engineer. I think all of us who've dealt with telecom and over the last 25, 30 years know very well what the term over engineering in telecom actually mean in terms of designs. But it's true that in the environment we're talking about, if you don't need to do something just because it says you need to do it in the spec, why do you need to do it? So I'm with you in terms of being able to allow users to relax it. I still think we will need one way or another to benchmark, and then the sum of the parts needs to be benchmarked too. I see it too often where people are reading off data sheets or asking you specifics about one piece of the system. And this is why I always come back to the end-to-end discussion of saying, well, how do you provide this with, I don't know, a network of N number of hops or, these capabilities, or are you expecting every single device in the path to have the same grade as a PRCA, a PRTCA type of capability, or do you assume that you actually have enough intelligence in your endpoint to deal with those situations? Because in other markets, I've seen people assuming that PTP is always there. And when it's not there, there is something that is there in order to make sure there is no logic anymore on the endpoints. And I would like to make sure we don't end up in get caught by that. Not by the people on this call are knowledgeable, but by the wider audience that will consume this technology once we put it together.
Absolutely, yeah. Like I'm trying to find like this one of these tests that I had basically for the whole, yeah, it's here, found it. So basically, Alad, can I share a screen?
Yeah, I'll make you a presenter. Just give me a sec. Here you go.
Awesome. So let's see, share. So can you guys see my screen?
Yep.
Yeah, so like this is basically, I think this was, yeah, this was in seconds because I couldn't just wait very long. So I basically had to write just like a daemon script that turns on or off, on or off, on or off, like constantly, like the synchronization to basically look at the behavior I have for the holdover. And you see every time, it's a beautiful thing. It's like nature, like every time you have a different footprint, because this is essentially the integral of that mistakenly consider, or like, oh, it's not, it's fine. You can consider the Gaussian noise. So, and then when you get that, you end up basically with this random walks. But then you see every time I have a different thing, and like how can I judge on this? And if you don't have enough knowledge about something, you end up with statistics, and I mean statistics is your only friend then. So let's say if I go with the specs will never tell me about this. Like you're not gonna get like a good understanding of what is going on there. And it was quite interesting for me. Like, I don't want to mention a name, like, but working with like different, let's say, vendors for test equipments and everything. And I brought it up, like, do we have a test like this that can show me what's going on? And they're like, oh no, we don't have such feature. And I'm like, this is like the most essential thing, because for me, let's say again, this scale, I have a requirement of, let's say here, 2 seconds. Assume this was actually nanoseconds. So my requirement, it's here, like 10 to the power 4 of a nanosecond. So this will be like 2 will be basically 200 nanoseconds. So let's say I have a 200 nanosecond accuracy requirement. So I can just line this up here, and then I look like, oh, okay, I have like, let's say 200 seconds that I can count on the holdover on a worst case scenario. And when I run this, let's say, I don't know, hundreds or millions of times or something, then I get like these things. But running this thing on my end as a customer is a pain, because I have to acquire every one of these lines basically in an experiment, serialize all these experiments, and you end up, let's say, for months sometimes. If I want to, let's say, do the holdover analysis, let's say for a day. So every one of those lines I have to wait a day. So instead, let's say if this goes straight back to the bucket of the oscillator vendor or something like this, over there, they're not running it on one device. They have like thousands of, like, I don't know, like, or they can hundreds, let's say. So their experiment will run 100 times faster than my experiment, and then whatever they have can be shared right away with everyone else. So this is one instance, and I hope like we can get more of such things, you know, like out of this, rather than just a funky number of like, okay, this was like the phase noise or something. I'm like, great, like, how can I really interpret that? How can I make my engineering decision on that? So that was like literally, Thomas, like what, like, I mean, it was one of the motivations, like how, like for like basically kickstarting this.
Sure, I understand.
Get this.
Yeah, that's a really interesting use case, Ahmad, because it particularly comes back to holdover characteristics, the drift of the oscillator, and how do we bound that not only per oscillator but across the whole manufacturing line.
Yeah. So how can I pull back, because I wanted to see.
Or did you want to share something else?
Yeah, I want to get out of the share so I can share another thing. Like, how do you do that?
I will share it again with you because it appears I need to do it each time.
I see.
Okay, you're the presenter now again.
Okay, so wait a second. Jeez, this is so counterintuitive. Not now. Oh my God. Okay. Yeah, so now let's see if I can share. So do you guys see this?
Yep.
This was basically what I had to create on my machine, and like these spikes are basically the overshoot of the controller when the controller figures out that there was like basically water slipping under, you know, like all of a sudden like had to go all this overshoots to control things back. So I basically had this like the controller, you see every once in a while go through things drift. You basically, the flat portion is when everything is in sync, and then you turn off and you wait for the drift, and you turn it on again, overshoot, and then turn off again, turn on there. And this, I would have thought like there must be like documents about like how you perform something like this. I couldn't believe like I had to basically reinvent this whole thing. Like this process doesn't exist. Like I was shocked, trust me, I was shocked. Like I have to like make this from scratch. I was expecting there should be a button right away you press, let's say in these measurement tools, and you get this over time. And if there is, and if I'm wrong, please correct me, because I'll be so happy if there is already a standard thing for doing this operation, because I think this is like one of the most important things I need to have in order to basically like have my confidence gauged of like how much can I now bank on like the holdover for my system. And this applies everywhere, Grandmaster or the NIC or even like boundary clocks. Okay, I think I can give it back to you. So the share screen. Okay, Elad, can you take it over from me? The share screen just blocking everything I can't do. Okay, good.
I got it, Ahmad. Thank you for that. One other thing that I just thought about that we probably need to address is where are we going to measure compliance? Is it going to be the output of the oscillator, or is it going to be at the system level? And if it's at the system level, can we use a Calnex box like Paragon? Or if it's at the oscillator level, are all the tests easy to do so that the manufacturer can do that and provide with some self-certification? But the point that we measure it is, I know that different standards like ITU-T, they measure it at the output of the network equipment. And other standards might measure it at the output of the oscillator. But another question we'll need to answer.
Yeah, I think it's a good question, and I would like to separate it from the certification question. I think certification can come after. I mean, as long as we agree on the framework and what has to be measured and how and what is the transfer function, certification can be either self or publicly made by a third party, but we can leave it for a much later time frame. I would rather focus on getting the transfer function of this framework in place. I think this is the key to get it all started.
Yeah, I think I agree with Elad. Like, I think what we can do is like we can also like bucketize it, or like basically have different levels of that. Like basically the first one is like how we have all these things, and perhaps we should also work with our colleagues in IEEE, have like certain standards. So these standards are there, and then you can define them with classes or something. Then you can just self-test them, and you see like, okay, like again with a device, with a Calnex or like whatever standard with an oscilloscope or any like data acquisition thing. So you get this, you see this, okay, self-reflecting. Okay, this is what I'm getting. The second one is now the self-reflecting is a little bit more serious, that now you use a standard device. Like for example, often what we do is like we take a Calnex device, and because Calnex has been used all over the place, and that way I have a good cross-reference that like I use the same Calnex Neo that is, let's say, calibrated and blah blah, all of these things are taken care of. That's my reference device. If that device is classifying, let's say, my boundary clock that as I developed here to a class B, let's say, then I can advertise as, hey, this is also class B. And this is like, I don't know how you want to put it, because this literally sits before the third, like most serious one, that everything basically has to be, let's say, measured and classified, like certified by one independent body. Like you basically send it over to let's say, again, perhaps we can find an agreement on, let's say, I don't know, maybe Calnex wants to do that, or someone else will basically act as this third party that will do the standards. Like basically similar to what you have in all the standardizing bodies, let's say you have in, again, backed by IEEE and everything and so on. And again, that really depends on why we don't want to do that. Like me as a customer, I can't care less about that. As long as I have a traceability of numbers that I'm getting to whatever is out there, I'm fine. So perhaps the second one is good for me. But let's say if you are a vendor, perhaps you want to have that third party, so that way there's no conflict of interest, there is no like there is a cross-reference on what you did, there is a third party that like approved that your like products sits per the standards that's advertised, and so on and so forth.
Yeah, sounds good.
And one more thing, like Elad, maybe it's not bad if I mention it. Overall, this is like a housekeeping thing with regards to our meetings. So as I make everyone notices here, So this meeting, like we're gonna have basically two types of meetings, like we're gonna flip-flop between the two from going from here on. Like this meeting is, I consider it more like a, what do you call it? Like internal meeting where, or like a discussion meeting that rather than a presentation, it's more like we're discussing things in, I call it family business. So like basically we discuss with things like how certain standards and so on, and engaging, and it's not just like a podcast-ish thing, you just listen to it and so on. And then we want to have basically, we want to flip-flop with another type of meetings, like basically we want to have in a month one of this and one of that. Again, depending on the demand, we might change that. And then a lot basically will have in the email, like also explaining which one it is. So when you guys attend the meeting, you know, you can gauge your expectation. And let's say the other meeting will be like more of like a talk, or let's say an external presenter we bring in and so on. And yeah, this is what we want to convey as we go forward.
All right. So let me just go ahead and finish out the.
Yeah, let's go to the call to action, and
Wonderful.
I guess we need to build the next steps.
Right. So as far as the methodology goes, what I envision happening is that we nail down the system level requirements first. This will mainly rely on the operators and hardware vendors to provide that. And then we'll map it into the component level specs, which will rely heavily on the component vendors' participation. And then we'll standardize them to different classes and specify test methods. And then it'll go out into the community to implement in the field and bring those test results back in, and we can iterate as needed. So the call to action is for system and oscillator vendors to join the workstream meeting. First meeting will be next week on Thursday, 9 a.m. Pacific. And in that meeting, we can decide on the normal meeting times and the cadence, but at least this will get us started for the first meeting. And so if you're interested to participate, please do email me. My linked email address is on the OCP TAP wiki page. And we hope that we get your participation so you can help us create solutions that that'll benefit you and your companies.
Okay, so again, if you want to reach out, either touch base with Gary, his email is on the wiki page, or with Kelvin, who is our overall TAP holder. And Gary, you will send out invitations to interested members, right?
Yep.
I think we should also send it in our email summary, so to reach out to the ones who did not attend today or the ones listening offline. Thank you very much, Gary. It's great to launch the fourth work stream, and we'll all look forward to the outcome of that.
Great.
All right, very good. Thank you so much.
Okay, we'll have, for the first time, we are finishing earlier.
Yeah. All right, all the best.
All right, thanks so much.
Bye, everyone.
Bye.
Thank you. Bye.